I can't.
Calculus is even more fun than parkour, and that's saying a lot. Okay, everybody. Corporate is making us learn a new way to find the limit of an indeterminate function. Okay, come on.
What is it?
It's called the hospital.
Actually, it's pronounced L'Hôpital. It's not the hospital.
Out.
I'm just trying to correct the name.
Why are you the way that you
I'm
are?
just trying to fix the name.
No, actually, Michael told me right.
Yeah, L'Hôpital is used when the limit of a function equals 0 over 0 or any
I knew that.
No, okay.
I knew that.
Yeah, you have to take the derivative of the top and bottom of a function until you find a value for the limit as x approaches c when c is inputted
I
into
knew
the
that.
function.
I knew that.
He knew that.
Okay, let's crack this. We can't have you messing up in front of corporate.
Come on, it's not even that hard.
No.
That hard. If you have to find the limit as x approaches 2 for the function x cubed minus 7x squared plus 10x over x squared plus x minus 6, what you do first is you find out if you really even need to use L'Hôpitals. Basically, in order to have to use L'Hôpitals, the function needs to equal 0 over 0. So, the best way to do that is we know that we're trying to find the limit as x approaches c. In this case, is 2. So you plug it into the function, and we get 0 over 0. Are you following?
Yes, I'm following.
Okay, just checking. So, next, we take the derivative of the top and bottom. So, for this particular function, it becomes 3x squared minus 14x plus 10 over 2x plus 1. Got it?
Yes.
Okay, got it. So, then what you do next is you plug in c again into the derivative function. So, you'd get 3 times 2 squared minus 14 times 2 plus 10 over 2 times 2 plus 1. Resulting, the limit as x approaches 2 would equal negative 6 over 5.
Whoop-de-frickin-do.
Are you ready to present it to
Yes,
corporate?
I'm ready.
Okay.
I'm ready.
Okay.
Hey, you moron. I used your stupid L'Hôpital's rule and I still got 0 over 0. Followed all your steps.
Just do it again. You can use L'Hôpital's until you get an actual answer for the limit.
Still getting 0 over 0. This rule is clearly ineffective.
Trust me, do it again.
Well,
Whatever.
Action.
Jim, come here.
what's up?
Dwight is driving me crazy. He thinks he's the smartest person ever, like a mathematician. How can you play with Harry Potter?
Do I ever?
Okay, so I made this continuities and discontinuities quiz.
Dwight!
What, you moron?
You think you're pretty smart, right? Duh. Alright, let's just take this test. Ready? Okay, are you ready?
I was born ready.
Just remember, in order for a function to be continuous at a point, it has to meet these 3 criteria. 1, f of c exists. 2, the limit of f of x as x approaches c exists. And 3, the limit of f of x as x approaches c exists and equals f of c.
I knew that already.
Okay, let's get started. This is the first function. Thoughts?
Not continuous.
Wrong. It's definitely continuous because there's a limit of f of x as x approaches c, and it equals f of c at the cusp. And even though this one is continuous, the derivative will not be.
Number 2. Thoughts?
This is obviously continuous.
Okay, don't get too cocky. Let's bring out the third one. Number 3. Thoughts?
Obviously, this is a trick question.
Not a trick question. The limit of f of x as x approaches 1 is different from the right side and from the left side, and this is a step discontinuity, so it's not continuous at 1. But at 6, there's an infinite discontinuity because of the asymptote, and if the branches aren't connected, then it's not continuous.
It is not, in fact, a trick question, Dwight.
Whatever.
Last one. Thoughts?
This is obviously continuous.
This is discontinuous. The limit of f of x does not equal f of c, even though f of c exists.
Moron.
Michael!
Okay, people, today's beach games. Please tell me the volume of a solid formed when the region in quadrant 1, bounded by the equation y equals x squared minus 4 and y equals 3, is rotated about the y-axis.
Alright, Michael, I'm done.
Michael, I'm done first!
Oh, well, looks like you guys both got the same answers. We used different methods. I don't know what to do.
Alright, let's look at mine first. I used the disk method to find the volume of the solid, which is also known as plane slicing. To get a better understanding, I graphed it. I rotated the area in the first quadrant about the y-axis. I then set up a sample strip perpendicular to the axis of rotation. I then picked a sample point xy on the graph. The thickness of the strip is dy. The volume of the strip is dv equals the cross-sectional area at the point times the thickness, which in this case is dy. I then set up the equation. I know I wanted it in terms of y because the thickness is dy. So I solved for x and got x equals the square root of y plus 4. Then I set up my volume of equation. I know my limits of integration are 0 to 3 because on the original equation the graph went from y equals 0 to the line y equals 3. I then plugged that all in, so I had volume equals from 0 to 3 pi times y plus 4 dy, resulting in the volume of the solid equaling 51.84 units cubed.
I don't know, Dwight. This looks pretty legit.
No, Michael, trust me. The cylindrical shells method is far superior. I also graphed it, but instead of using a disk like a moron, I used the cylindrical shells. Basically, dv equals the circumference of the shell times the height times its thickness, which in this case is dx. So, I set up my equation. Because the height is y and y equals x squared minus 4, I can just plug in on the right side. So the whole equation is in terms of x. Then I use my genius to discover that the limits of integration are 0 to 2. So basically the volume of the solid equation is v equals 2 pi x 3 minus x squared minus 4 dx. My final answer, 51.84 units cubed.
All right, I guess both methods work then.
Mine's better.
Bears beats calculus.
Guys, identity theft is not a joke. Millions of families are affected every year.